For number 20, we're dividing polynomials, and we're going to do synthetic division. So that's x plus 2 divided into x to the 4th minus 3x squared plus 1. So what we do, if we have the x plus 2 here, we put a little minus 2 in this half box. Then we write the coefficients of the polynomial that we're dividing into. So that's 1 for x to the 4th. Put in zeros for missing coefficients. So x cubed is missing, that gets a 0. And for x squared, we have a minus 3. Then x is missing, that gets a 0. And 1. Okay, now let's put down a line, leave an empty row. And we start by bringing down the first coefficient, bring down the 1. And we use this minus 2 to keep on multiplying. So we'll multiply minus 2 times 1. We get minus 2 and add. And there we have minus 2. Now multiply. Minus 2 times minus 2 is 4. And add. And we get 1 over here. Minus 2 times 1 is minus 2. And add. And here we have minus 2. Now multiply and we have a plus 4, and add and we have 5. This is our remainder. And these are the coefficients of our quotient. So that our quotient will start with x cubed, okay, because we go down one exponent. So that would be 1 times x cubed minus 2 times x squared plus 1 times x minus 2, and remainder 5. Okay, we have number 21, we have y is equal to 2x, 2 to the x. And we want to first of all graph that. So we'll start at point at above x equals 0. 2 to the 0 is 1. So this goes through 0, 1. And we saw in class that 2 to the x goes up very rapidly on the right. And has an asymptote at the left at y equals 0, or the x-axis. So it dies down towards 0 as x goes to minus infinity. The domain is x between minus infinity and infinity. And the range, you see the graph is above the x-axis, so that's y greater than 0. Okay, number 22, we have 2 to the x is equal to 1 over the square root of 8. And we want to solve for x. So in this case, we can write 1 over the square root of 8 as a power of 2. All right, so let's do that. First of all, 8 is 2 cubed. So we have the square root of 2 cubed. So that's 1 over 2 cubed to the 1/2, which is 1 over 2 to the 3/2, and that's equal to 2 to the minus 3/2. So now we have the same base on either side. We can just match the exponents. So x is equal to minus 3/2. Okay, here in number 23 we have 3 to the 2x plus 1 is equal to 1. On the right-hand side, we can write 1 as a power of 3. Okay, 1 is equal to 3 to the 0. So we're going to match exponents like we did before. So 2x plus 1 is equal to 0. 2x is equal to minus 1. And x is equal to minus 1/2. Here's question 24. 2 to the 3x plus 1 is equal to 4 to the 5x minus 2. So we could write the right-hand side as a power of 2. All right, we put 4 is equal to 2 squared, so that would be 2 squared to that same exponent, 5x minus 2, is equal to, and then 2 to the 3x plus 1 on the right-hand side. And now let's just multiply exponents here. So we have 2 to the 10x minus 4. All right, and now just match exponents, and we have a simple linear equation. Okay, we'll subtract 3x from both sides, add 4 to both sides, 7x equal 5, and divide by 7. And x is equal to 5 over 7. Okay, number 25 says that we have $500 invested at 5% compounded continuously for 10 years. What's the amount after 10 years? All right, so the continuously compounded formula goes as follows. The amount after a certain number of years is equal to P, that stands for principal, the amount that we start with, times e to the exponent RT, where R is the yearly rate. All right, so that would be, in our case, P is 500. R, we write 5% in decimal form, 0.05, times 10 years. T is 10. Okay, so that's 500. E to the 0.05 times 10, that's e to the 0.5. And let's see, what's that? Okay, so e to the 0.5 is about 1.649. So that's equal to $824 after 10 years. Okay, number 26 asks, what's the inverse of y equal to 5 to the x? Well, that's how we define log functions, as the inverse of these exponent functions. So the inverse is y is equal to log base 5 of x. That's the inverse function. And let's see, number 27 asks, what's the inverse of y equal to e to the x? So that would be y equal log base e of x, but we have a special way of writing that. We write that as ln. ln stands for log base e, ln of x. And sometimes we pronounce this ln x. Okay, here we're writing log expressions for these exponential equations. So for the first one, we have a base of 2, so that would be log base 2. And here's our exponent, so the log base 2 of 8 is equal to this exponent of 3. Remember, logs are exponents, so we put the log equal to the exponent. The log on the left-hand side, exponent on the right. Okay, let's continue here with the next example. So here we have log base 3. The log base 3 of this number is equal to minus 2, this exponent. Log base 3 of 1/9 is equal to minus 2. And the next one we have log base 4. Log base 4 of this number, log base 4 of 2, is equal to 1/2. And here we have the log base 10. Log base 10 of this number of 0.01 is equal to the exponent minus 2. Okay, let's evaluate this expression, log base 2 of the square root of 32. All right, so if this were 2 to an exponent, the answer would just be whatever that exponent is. So this can be written as 2 as a power of 2, or 2 to an exponent. So let's do that. Log base 2. This is 2 to the 5th to the 1/2. and that's log base 2 of 2 to the, multiplying these exponents, we have 5/2. So what exponent of base 2 do we need to express 2 to the 5/2? Well, that's sort of a redundant question. 5/2 is the exponent of 2 that gives 2 to the 5/2. Number 30 asks, what is the ln of e to the 4th? All right, ln, remember, is log base e. So this is, again, sort of one of those obvious questions. What exponent of e gives us e to the 4th? Well, it can only be 4. Okay, here's another one. This is the same as ln e to the 1/2. What exponent of e, remember this is log base e, what exponent of e gives us e to the 1/2, so it could only be 1/2. Okay, here we're asking what exponent of, here I'll write this on the side, 1/3 is the base. What exponent of 1/3 will give us the number 9? Well, 1/3 to the -1 is 3, so 1/3 to the -2 is 9. Okay, just flip this and we have, this is the same as 3 squared, which is 9. So here we have 9. And here we're asking 10 to what exponent is equal to 1,000? Well, 10 cubed is equal to 1,000, so that would be 3. Okay, number 34, we want the domain and range of y equal ln x, and we want a sketch of the graph. So remember, y equal ln x is the inverse of y equal to e to the x. So let's remember what this graph looks like. Y equal e to the x, this exponential. It goes through 0, 1. E to the 0 is equal to 1. It goes up pretty steeply on the right, and it has an asymptote on the left, goes down to the x-axis. All right, that's y equal e to the x. So let's see if we can, from this graph, if we can get the graph of y equal ln x. And we'll use what we want to do is we want to switch the roles of x and y and then do a reflection. All right, so let's see how that works. Okay. All right, so this is y equal e to the x, and here we're going to rotate it. Let's do that. Okay, there we go. We rotated it 90 degrees. And now what we're going to do is we're going to flip it about this vertical axis. Okay, so let's do that. Let's see if we can do that here. Here we go, flip horizontal, and that's it. There we have it. That's the graph of y equal ln x. This point is now, okay, this point here is 1, 0. This is our x-axis, and this is our y-axis. And that's the graph. And so from here we can see the domain and range. Well, the domain, you see the graph is entirely to the right of x equals 0. So the domain is x greater than 0. And the range, well, the graph does go all the way down here, down to -infinity, and it climbs up slowly to infinity. So it covers all y values. It goes all the way up slowly. and shoots down over here. So the range is y greater than minus infinity, less than infinity. Okay, that's the range.